viewers, welcome to my channel. I'm Hasham Ali Khan. Now I'm going to start a new topic, Travelling Salesman Problem. Actually, this is a part of assignment problem. In the previous videos, I have completed nearly some 10 problems on assignment. Similar, this Travelling Salesman Problem, TSP, that is also similar to assignment problem only. Actually, in OR subject, in this unit number 3, we have 3 topics: transportation problem, assignment problem, and traveling salesman problem. Actually, traveling salesman problem are not at all different from assignment only. One extra step is there. In examination, you may be asked a theory question: what is traveling salesman problem? It's a problem in which one salesman starts from a particular city, visit each other city only once, and he has to come back to the home city. So in what is the sequence in which he has to visit the other cities and come back to home cities in the shortest possible distance, or shortest possible time, or shortest possible cost. The ultimate objective is to find out the sequence in which the traveling salesman has to visit all cities only once and come back to home city in the shortest possible time or distance. That is the problem. So already I have discussed this in the assignment problem theory videos. So if you have watched that, it's okay. Otherwise, you go to the playlist of my channel, select the subject operation research, select the videos of assignment problems. Watch the theory, first 2 theory videos on assignment. You will get there the theory of TSP, traveling salesman problem. Now I have selected 3 problems on this TSP. So before starting the first problem, I expect my viewers to have a printout of the problems of TSP, which is given in the link under my description. Take the screenshot of the points, then I'll explain. Come on, I'm starting the first problem. A salesperson travels from one city to another city. The distances between pair of cities are given below. So here from to, from city A, B, C, D to city A, B, C, D. The distance is how much is given? From A to A 0, because there is no distance at all, same city. From A to B 15 and A to C 25, A to D is 20. This is the distance from A to B, C, D. Similarly, from B to A, B to B. B to B, we don't have any distance. C to C, we don't have. D to D, we don't have. Suggest an optimal route to each salesperson which enables him to visit each of the cities only once at the minimum total distance traveled. So here distance is given. How much is distance from one city to another city? So suppose if the traveling salesman is starting from A city, he has to visit B, C, D only once and come back to home city A. So which path, which route he should follow? From A, he can go either to B or C or D. Suppose if he goes from A to B, from B, he can visit either C or D. Similarly, first time he can go from A to D, then C to then B. Like the different paths are available. So we have to find out that path through which the distance traveled should be minimum. Same steps we have to follow what we have done in assignment problem. But after getting the solution of assignment, we have to check whether it satisfies that condition or not. Which condition? He has to visit every other city only once and then he has to come back. In between, he should not come back to home city. Only after visiting all other cities, he should come back to home city. That is the extra condition in TSP, right? So first step as usual. So values are given in the problem from A. So first step is row subtraction. Same steps what we have done in assignment problem. Row subtraction. subtract the smallest element in each row from the corresponding element of that row. We get the reduced matrix as follows. So first, ignore 0. 0 means it should not be calculated. It should be ignored completely. The first row minimum is 15. The values are 15, 25, 20. Right? Minimum is 15. So 15 minus 15, it is 0. 25 minus 15, it is 10. 20 minus 15, it is 5. First row completed. Second row minimum is 22. So 22 minus 22, it is 0. Right? Then next one is 45 minus 22. So we can calculate 45 minus 22. It comes to 23. Next comes 55 minus 22. 55 minus 22. It comes to 33. Next, 0. In 0, minimum is 40, 30, dash 25. So 25 is minimum. So 40 minus 25 is 15. Then 30 minus 25 is 5. Next dash, 25 minus 25, 0. Last row, minimum is 20. So 20 minus 20, 0. Here 26 minus 20, 6. 38 minus 20 is 18. That's all. So first step completed, that is row subtraction. Now I am coming to the second step, column subtraction. Subtract the smallest element in each column from the corresponding element of that column. And after completing this column subtraction, draw the minimum number of lines so as to cover up all the zeros. That is the second step. So first column, the minimum is 0. When 0 is the minimum, same values, 0 minus 0. First of all, you put A, B, C and D. A to A dash, B to B, C to C, D to D. Now we'll take the column. First column minimum is 0. If you subtract 0, you will get the same value 0, 15, 0. Second column again 0 is there. 0, then dash, 5 and 6. Third column minimum is 10. Now subtract 10. 10 minus 10, 0. 23 minus 10, 13. 18 minus 10 is 8. Last column minimum is 0. So same values will get 5, 33 and 0. That's all. Now we have to draw the minimum number of lines covering the zeros. So in column wise, if you see in one line, vertical line, we can cover up 2 zeros. Here 1 0, here 1 0, here 1 0. If we go row wise, here 2 zeros, 1 0, 1 0, 1 0. So maximum 2 zeros we can cover up in a single line, in vertically as well as horizontally. Vertically, if you see here, this vertical line covers up 2 zeros, and this horizontal line also covers up 2 zeros. Only 1 0 is left. You can cover up this 1 0 either vertically or horizontally. Any way you can cover up. So I am drawing a vertical line, so it is becoming like this. You can draw horizontal also, doesn't matter. So how many lines are required here to cover up all the zeros? 1, 2 and 3. 3 lines. But what is the order of the matrix? 4. 4 rows and 4 columns. So it is not an optimum solution. Optimum solution will be reached when number of rows, number of lines must be equal to the order of the matrix. Both should be same. It is not an optimum solution. Now what is the next step? Already we have done this in assignment problem. The minimum uncovered element. Here you can see the minimum covered, uncovered. This is uncovered, whereas the line is covered. Wherever line is there, that is covered, and without line are uncovered. So which is the minimum uncovered element? 5. So subtract 5 from uncovered elements, add 5 at the point of intersection, and keeping the other values same. After doing that, again drawing minimum number of lines to cover up all the zeros. The minimum is 5. This is, first of all, put a dash. This one dash, 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 dash. A, B, C, D, right? Now here, 0 is covered, the same values. This is intersection, so 5 plus 5 is 10, right? Here 0 is covered, same. Then 13 minus 5 is how much? 8. 13 minus 5 is 8, right? 33 is covered, same value. Here 15 is covered, same value. 5 minus 5, 0. Then 0 is covered. Here 0 is covered. 6 minus 5, 1. 8 minus 5 is 3. That's all. Now again drawing minimum number of lines so as to cover up all the zeros. So how many lines? See here, 2 lines are there in the row. Then 1 0, 2 zeros are there. Here 1 0, 2 zeros, 1 0. So maximum 2 zeros. Column wise 2 zeros, 2 zeros, 1 0, 1 0. So maximum 2 zeros we can cover up in a single line, vertically as well as horizontal. So vertical, this vertical line I am drawing, 2 zeros are covered. This is the horizontal line, 2 zeros are covered. This is also horizontal line, 2 zeros are covered. So all the zeros are covered. How many lines are there? 1, 2 and 3. That means number of lines are 3, but the order of the matrix is 4. 4 by 4. It is not an optimum solution. What is the minimum uncovered element here? 1. Now again same procedure. Minimum uncovered element is 1. Subtract 1 from uncovered elements. Add 1 at the point of intersection, keeping the other values same. After this, again drawing minimum number of lines. So here table number 4. Dash, 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 dash. So first 0, 0, 10, same value because covered here. Here 0 covered, same value. Then 8. 8 minus 1 is 7. 33 minus 1 is 32. Here 15 plus 1 is 16. 0 covered, same. 0 covered, same. Here 0 covered, same. 1 minus 1, 0. 3 minus 1, 2. That's all. Now after this, again drawing minimum number of lines. So maximum how many zeros we can cover up in a single line? 3 zeros we can cover up in the vertically, column wise. Right? Here 2 zeros, here 1 0, 2 zeros, 2 zeros. Right? Column wise 3 zeros, 1 0, 1, 2 zeros. So first one line we have covered up these 3 zeros. Right? Now 2 zeros we can cover up in this vertical line. So 2 zeros I have covered up. Now remaining 2 zeros are left at 2 different places. So we can cover up this 0 either horizontally or vertically. And this 0 also either vertically or horizontally. We cannot cover up both the zeros in one line. 2 separate lines are required. I am covering up like this and like this. Anyway you can draw. So totally how many lines we got? 4 lines. Order of the matrix 4. So we got the optimum solution. So for optimum assignments, take the same values, dash, 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 dash. 0, 0, then 10, then 0, here 7, then here 32, then here 16, 0, dash, 0, then 0, 0, 2. That's all. Now we have to give the assignment. How to give the assignment? Already we have done so many problems in assignment. See, locate in a single row if any 1 0 is there. In a row, if there is only 1 0, assign that 0. First of all, first row 2 zeros. Second row we have only 1 0. So assign this 0. When you assign this 0, cancel the other zeros in that column and row. In that column, this 0 will get cancelled, no other 0. Any other row having a single 0? Yes, D row we have a single 0. So assign this 0 and cancel the other zeros in that column and row. Any other row having a single 0? Yes, A row we have a single 0. Assign this 0. No other 0 in that column and row. Lastly, C row is also having 1 0. So assign this 0. Now you can see all the zeros are either assigned or cancelled. That is the final solution. Now we make the assignment. How we have given the assignment? A to C. So here you can see A to C. Then B to A, B to A. Then C to D, C to D. And D to B. So it can be written as A to C, because from A, suppose if the traveling salesman is starting from A city, so first he is visiting C city. From C city, he is going to visit D city. From D city, he is going to visit B city. From B city, he is going to come back to A city. So there is a complete loop formed from A to A. From A, he should go to C. From C, he should visit D. From D, he should visit B. From B, he has to come back to A. So there is a complete loop from A to A. So this shows that it is the solution of TSP. In between, he has not come back to A city. After visiting B, C, D once, he has come back to A city. That is the final solution of TSP. So it is a solution of TSP. The optimum assignment and this total distance is as follows. A to C. Now you can go to the original problem and see what is the distance for A from A to C. It is 25. Then from C to D, it is 25. From D to B, it is 26. Then B to A, it is 22. That's all. So now we find out what is the total. Total is 25 plus 25 plus 26 plus 22. It comes to 98. So 98 is the total minimum distance in which he has to visit, so that this path if we follow, then definitely the total distance traveled will be minimum. That's all. This is the first problem on TSP. First problem. Similar problem, two more problems inshallah will continue in the next video.